So the first thing that comes in sequences and series is like the general orthodox questions, where like you have straightforward formulas and all. But there are some questions such as this one, which is you have to find out the sum for, which doesn't look like a arithmetic, which doesn't look like a geometric. So how do we solve this kind of question? So generally, this is not in typical IB question, but sometimes for just for practice, you can do it. So here, our first step is to actually get something, get a way how to visualize our previous knowledge in context to this problem. So what we try to do is try to first take 5 common. If I take 5 common, it becomes like 1 plus, let's say, 11, then plus 111, and so on. And we are doing this. I first time when I was trying, probably I would be also not able to think in the same way. But with the practice part, we become like expert at thinking like this kind of question. So anyway, so now next step is to actually multiply and divide by 9. So the only reason we are doing is that if I take 5 by 9 now outside, inside can be written as 9 plus 99 plus 999 and so on. And if you do this, now we have to do one more adjustment, which is, so this 9 I took inside and this 5 over 9 I took outside. And then this becomes basically 5 over 9 outside. And this one is actually, I can write down this as 10 minus 1 plus 100 minus 1 plus 1000 minus 1 and so on. So when you look at this part, the 10, 100, 1000 and all, this is like forming a geometric sequence. And so that's what we do is we pair them up together. So 5 over 9 outside, so it'll be 10 plus 100 plus 1000 and so on, and up till sum of first n terms, you can say, and minus, because you're doing -1 n times, so that's how it'll be like -1 n times, which is nothing but -n. So that takes account of these negative ones that you get, because there will be n negative ones. So that is, if I add -1 -1 -1 n times, it'll be -n. And now comes is this part, which is obviously the geometric sequence. You can apply the formula for sum, which is 5 over 9. And what we get is SN formula is U1, ratio is 10 to the power n minus 1 over 10 minus 1, and minus n, of course, here. So as a result of this, what we get is 5 over 9 times 10 over 9, and this will be 10 to the power n minus 1 and minus n. And of course, if you open up the bracket, it will become 50 over 81, 10 to the power n minus 1 and minus 5 over 9n. So that's how you find out the sum of this particular, like it's a formula that you derive for sum of this particular series. So here's the second example of this previous type question. So first step, what you're going to do is, once again here, we're going to take the 6 common, so that we get like 0.1 plus 0.11 plus 0.111 and so on. And generally, our intention is to reduce it to like something like either it's 999, 999 and so on. But since you can see here is decimal involved, I would not mind like multiplying here itself 9 and 9, multiply and divide by 9. And so 6 over 9, you take it outside and multiply this 9 inside. So it'll become 0.9 plus 0.99 plus 0.999 and so on. And now as a result of this, what you notice is that I can write down the 6 over 9, and first number 0.9 can be written as, this can be written as, I'll just erase this. This can be written as 1 minus 0.1 plus 1 minus 0.01 plus 1 minus 0.001 and so on. So now as a result of this, what you notice is that this part is actually like you're adding 1 n times. So it'll be 6 over 9. If you add 1 n times, that's n. And minus, if I take like 0.1 is actually 1 over 10, 0.01 is 1 over 100, and 0.001 is 1 over 1000, and so on. So again, once you notice here, it's a geometric sequence, it's geometric series. So you can just do 6 over 9 n minus u1 is 1 over 10 and 1 minus, I can use the second formula, first formula for sum of first n term, that's okay. So this will be 1 upon 10 minus 1. I mean 1 minus 1 upon 10. And if you simplify this, here I applied the formula for sum. Sn is u1, 1 minus r to the power n over 1 minus r. This is to the power. So now this is, if I simplify this part, so which is 6 over 9, n minus 1 over 10, and this is 9 over 10. So this will be 1 over 10 and divided by 9 over 10. So this 10 and 10 get cancelled. So you get 1 over 9 outside the bracket, and it'll be 1 minus 10 to the power n. And if you simplify the final answer, it's going to be 6 over 9 outside, n minus 1 over 9, and 1 minus 1 over 10 to the power n. And if you wish to open the bracket, it can be written as 6 over 9n, which is obviously 2/3 n, minus 6 over 81, 1 minus 1 over 10 to the power n. So that's how I find out the sum of this particular series as well.